solving simultaneous equations by drawing straight line graphs. Remember, that's the one time that is more likely a question will specify a method to you. If they don't specify a method, then you can use any method. This method that we're talking about today is the most common way of solving simultaneous equations. So, what it involves eliminating, good name for it, isn't it? The elimination method. We're eliminating, which means getting rid of, one of the variables to allow you to solve for one letter, and then you substitute that value into either of the other two equations in order to find the other one. Now, I haven't specified eliminate the x or eliminate the y because you can choose to eliminate either of them. One will be more, not preferred, will probably be easier than another, but you can eliminate either the x or the y, it's up to you. So, eliminating one of the letters is done by adding the two equations once you have one term that will disappear when you add them together. But what makes something disappear? As I've said here, for this to happen, the coefficient of one of the letters needs to be the same, but with different signs. So in other words, one has to be positive and one has to be negative. Because if I were to add negative 7x and 7x, hopefully you will tell me it's 0, yes? If I add 5y and negative 5y, I get 0. You get the gist? So in order for things to be eliminated when we add them, we need to have the number in front of it the same, but different signs. So one has to be positive, one has to be negative. Okay, so far so good? If this criteria is not met in the original question, you will need to multiply one or both of the equations by some value in order to make the coefficient the same. Each term in the equation must be multiplied by the same number, but if you need to multiply both equations, you can multiply them with different values. Now, that's a lot of words. It's much, much easier once we get going with the actual example. Right, so here's our first example question. Solve 3x plus y equals 5 and 2x minus y equals 10. Now, I don't know about you, but if I'm adding things, I like to have them one on top of the other. Yes? So I'm going to rewrite this. 3x plus y equals 5 and 2x minus y equals 10. So all I've done is, because what's going to happen is I'm going to add my equations. Now, I've written them like this, partially because that's what the original question had, but it also means that my x values are in one column and my y's are in another. Yes? Yes, that will be the next example. I've tried to do, each example I've given you is going to have one slight reason why I've chosen that example. Alright, so we're going to add these two equations. Oh, sorry, what I should have said first was, what's the number in front of x here in this one? And this one is is that the same number? No. No, okay. What's the number in front of this one? 1. And what's the number in front of this one? -1. What's the number in front of it? So this is a 1, and this is a -1. Is that the same number but different signs? Yes. Yes. Okay, so this is good to go. So what we can do is, what I tend to do is draw a box around it and cross it out, because I've got plus y and minus y, so I know that they are going to merge together when I add them to become nothing. You all understand that? You see why it's going to merge? Yeah. And so literally I'm just going to add them now. So 3x plus 2x is 5. My equal sign stays there, and 5 plus 10 is 15. So we've eliminated the y's, so all I'm left with is an equation with an x, which means I can now solve it. If 5 lots of x is 15, x would be 15 divided by 5, which is 3. So I know my x value is 3. Now, lots of people get very excited with themselves, pat themselves on the back, say, check me out, done, off we go to the next question. However, we haven't found the value of y. So you haven't finished yet. You now get a choice though. You can stick this value, sorry, I should substitute this value into either of these two equations in order to find y. If when you substitute your value into either of those equations you get a different answer, it means something's gone wrong. Whether you've got the wrong value of x or you substituted incorrectly. Okay? So, do you want to do it in this first one or the second one? First? Okay. So I know the value of x is 3. So that means instead of writing 3x plus y, or let's write that to start with, I'm going to now write 3 lots of 3 plus y. Do you want to see that? Because x was 3. So I replaced my x value with the number 3. Oops. So that's 9 plus y equals 5. So y is 5 subtract 9, which hopefully you're happy is -4. So that's my second value. So x is 3 and y is -4.
How do you record this?
Yeah. Just it disappears when I press. Say again? No. So these have to satisfy the same, both equations. So if I want to check, then these two numbers, when I stick it into this equation, should give me 10. So it should be that 2 lots of 3 take away -4 should equal 10. So 2 lots of 3 is 6. When we're taking away a negative, we're adding, equals 10, so we're good. So this blue set here was my check to see that they satisfy both of them. You don't have to do that, okay, but you can if you want to. If you have time at the end of your exam or your test, then that's a good option to spend some time doing that. Yes, good. Right. Next one. So solve 2x plus 3y equals -6 and y minus 2x equals 40. So again, normally we would write them one above each other, and Lara, this should answer your question. Because my second equation says y subtract 2x equals 14, I'm actually going to rearrange that. So what would I start off with? -2x plus y equals 14. So this second one here is just a rearrangement of this one here. Yes.
So the other concept that you put the part is the same?
No. It will always be that you're eliminating either the x's or the y's, because you can only solve the equation with one unknown. Right, so once we've rearranged, we have a look at these. Do we have the same coefficient but different signs in front of either the x or the y?
Yes.
Yes. So which one is it? The x. So that means I'm going to draw a box of these babies and just put a line through because I know that they're going to disappear. You can show that you're adding them. And we've got positive 3y plus another y gives me 4y. And then we've got -6 plus 14. Just 8. So we've got one unknown now, so we can solve it. So 4 lots of y is 8, then y is 8 divided by 4 is 2. So our value of y is 2. That's our exercise. case, for whatever reason, that we often end up working out or finding the value of x first. In this particular instance, we found the value of y first. Just be careful that when you now go on to find the value of x, that you are substituting this value into the correct position, because that's something that people do make mistakes on. They work this part out quite nicely, and then they stick the value of 2 in place of the x, because that's what they've been doing in so many of their examples. But just check where it should go. So we know y is 2. I need to find the value of x. Are you wanting, or are you tempted to stick it into the substitute? Stop saying stick. Substitute it into the first or the second? Not the second?
I want a second.
Because there's a negative in
Okay, so did we all hear that?
Yeah.
Yes.
Maybe it's here?
No. Well, I did, but I just don't understand it.
So we know the value of y. We're trying to find the value of x. But what sign is stuck in front of this x here in the second one? Negative. So it just means that we are making our life a little bit harder if it's got a negative sign in front of it. You can still do it. It just means that there's more room for error. So in this case, I would definitely substitute into the first. So we've got 2x. Oh, I did that last time. So I've written it out, and now I'm going to say that 2x plus 3 lots of 2 is equal to negative 6. Okay, so I've substituted in my value. Pardon?
No, not in her.
So 2x plus 6 equals negative 6. What do we do now? We subtract 6 from both sides, yes? So 2x equals negative 6, subtract another 6. So that gives us negative 12, not 0. And then x is negative 12 divided by 2, which is negative 6. And there's our x value. As we did before, feel free to then substitute both of those two numbers into the second equation to check that they are right.
When you were substituting in y, could you look
Yeah, you totally can. It's just that, as we discussed, because it's negative 2x, it just makes it a little bit harder. Not a little bit harder, it just because people don't really work well with the negatives. So if you can avoid them, it's good too. Okay? Just as a side note, if we were to write this as a coordinate, what would my coordinate be? Negative 6, 2. Hoping someone would say 2 negative 6. Okay, always make sure that you've got your x value comes first. Alright, next one.
So,
Oh, I'm so sorry.
I know, I'm talking to the target.
Oh, hush now. That's good. So I can continue.
We like have some aggression. What was that loud? My son's going to die with that.
Alright, so I've got 5x take away 3y equals 13. And 2x plus y equals 3. So is the number in front of the x's the same but different signs?
No.
No. Is the number in front of the y's the same but different signs?
No.
No. Okay, so this is where we have to start having to do an extra step. It's not traumatic though.
Everything's traumatic.
All it is that you have to say to yourself, okay, I need to make the number in front of either the x's or the y's the same value but different signs. My temptation here is, because I've already got a positive and a negative value in front of the y, I'm going to try and make this number the same. That, yes? So, given?
So, do you multiply by different numbers?
Yes. So, I've already got a 3 here. What number do I currently have here? 1. So, how can I make it the same value? Multiply by 3. Now, this is the same here. If you're going to multiply it by 3, you must multiply everything by 3. Not just the y. Okay, so we need to multiply the whole equation by 3. So that is now going to become 6x plus 3y equals 9. Now, it happens to be the case where I say this and everyone nods, smiles at me and says, yes, I understand and I'm going to do that. And then when it comes to it, they forget. And they especially tend to forget the number on the end. Okay, so prove to me that you are my exceptions to my norm and that you are not going to do that. Alright, so I'm going to rewrite my other equation just underneath it, just so it's easier to add it, so it's closer, so it's right next to it. Yes? I love when full sentences come out. So I'm going to put my box around my y's because they are the ones that are going to disappear. I'm going to put an add sign, and so go ahead and add them. So 6x plus 5x gives me 11x, and 9 plus 13 is, and so x 22 over 11, which is 2. Oh my god. I'm really so tired. Alright, so we found our value for x. We pat ourselves on the back and say, right, check you later. Or we now have to finish our question. Now, at this point, you've got 3 options.
Oh my
Then you
god.
had the original 2, but now you've got the blue one as well.
Laura's confused.
What are you wearing?
Oh, because I have all that written down, so I was just assuming
Oh, I
you went
see.
straight to the 2 when you could have
No. Alright, so here you've got 3 different options that you can substitute your value for x in to find your y. And you will get the same answer no matter which one you choose. So it really doesn't matter. My inclination, which one do you think my inclination would be to substitute? Like 1, 2, or 3?
3.
3.
3.
Mine would be the 2.
Yeah. Why?
No, the other wants to do the one that I want.
So
The first one, I'll do the second one. So that's
the reason I would choose this one is because I need to find the value of y. Yes? And so this already has just y on its own. I don't have to do any final dividing for this one. You can totally put it into number 3 or number 1. And number 3 is also a positive value for y, so that's not going to cause any issues, but you do have to do the dividing by 3. So why do that if you don't need to? So I'm going to substitute it into number 2. So I will have, let's, 2x and y equals 3. So 2 lots of 2 plus y equals 3. 4 plus y is 3. Y is 3, subtract 4. So y is equal to 1.
Forgot to put that sign right here because they get annoyed at you.
Yeah, they should. Alright, so are we feeling happy about the setting out of them?
Yeah.
Yes? And our aim of the game is to get that number in front of it, the same value but different signs. Oh, I apologize. Oh my god. Oh, I'll wait.
Oh, why did I put it 13? Not sure. Because 13 was number 1.
Oh, it was 3. Oh, 2 times 2 is 4. Yeah, we're good.
Remember, we've got 50 cents. Not that one. Oh, lovely. Right, okay. So again, I'm going to write them one above each other. 3x take away 2y equals 2x minus shush, please. So now we've got our questions. Is the value in front of the x the same but different signs?
No.
No. Is the value in front of the y the same at different signs? No. So, pardon? You don't know what I mean?
No.
Oh.
I said you believe.
Oh my gosh, girls, calm down. So, we need to do something now to both of our equations because there is no way that I can multiply one of these equations by a value and end up with the same coefficient for the other. Okay? When it comes to choosing which one you're going to make the same but different signs, first of all concentrate on making the value the same. So at the moment I've got a 3 and a 2 here, I've got a 2 and a 3 here. So you can choose whether it's the x value that you're going to make the same or the y value that you're going to make the same. If you've already got one is positive and one is negative, then go with that option. But in this case, these are both positive and these are both negative, so it makes no difference. Okay? So let's do the class that's the loudest, or the people that are the loudest. So we make x the same or x. Okay, oh gosh. Alright, so we need to make this number here the same as each other. So what do I have to do to the top equation? I have to multiply that by 2. And what do I have to do to the -3? Oh, okay, right, yes. So you've got a choice here. You can either multiply it by 3 and then change the signs of everything, or you can multiply by -3. Are you happy with multiplying by -3 to make sure that they're opposite signs?
You always just switch it around.
Mine is not okay.
All right. So do you know what? I'm gonna go with 3 for now,
Yeah.
and then I will deal with the fact that they're different signs. No, not at all.
If you're comfortable with multiplying by -3, please.
Definitely 3 is.
Oh, why do we not have 4 options?
Right, because we chose, because Lara was the loudest, to be honest, that we wanted to make the number in front of the x the same. So what we say to ourselves is, I know I need to get bigger, so it's got to be bigger than 3 and bigger than 2. So which number is in the 3 times table and the 2 times table? And that number is going to be the 6. Now, if, as Aria said, you chose to make them both 12s, totally fine. You can make them both the same. Whatever number you choose, you will get the correct answers. But you just have to make sure that you are making them the same value. Yes, so ideally you're looking for the lowest common multiple, but it doesn't have to be. Okay? So the first one multiplied by 2 gives me 6x, take away 4y equals 14. Hopefully you'll remember to multiply the end one. And the second one is going to be 6x minus 9y equals 9. Now, we can't put our box around the x's yet, because they have the same signs. Okay, you did it by negative. So because these are the same sign, all I have to do is to change one of them to be all of the opposite signs of what they were. Now, that doesn't have to be the green one. You can choose to make the black one or the opposite signs. But whichever you choose, you have to change everything to be the opposite. Okay? So let's change the green one just because some people multiply by -3 straight away. So this means that this is going to become -6 plus 9y and -9. Are you happy with that, Natanya?
Yeah.
Anyone else that wasn't happy with multiply by -3, you're good now? Yeah? So now they are different signs, I can put a box around them and ditch them. I hear you, sister, but some people don't know how to put it.
Wait, do they have to use
Yes, because that's the only way that they can add. Yeah, that's very personal. Right, okay. Those news. So let's go. Negative 4 plus 9.
5y.
So it's 5y and 14 plus negative 9.
5.
So y is equal to 5 over 5, which is 1. So again, oh, I'm sorry, darling. You've now got lots of different choices to find our value of x.
Option 4.
No.
Option 4.
That's the worst
That's
option.
the worst one because it's negative.
Do option 3.
So, I'm actually going to go with the second
You're
one.
kidding.
There's 2 lots of
Not
it.
one.
There's fewer of them. So y is 1. That's the value I'm sticking in. So I've got 2x minus 3y equals 3. You can choose whichever one you want. I can't stress this enough. So 2x minus 3 equals 3. I've run out of room. 2x equals 3 plus 3. Got it. So x is 3. Trace the hands?
Give me a sec.
Okay. Yes, madam. Oh, we're 26 minutes. Okay, next one. I chose this one. Why didn't I choose this one?
Because it has different letters.
It has some different letters, but it makes no difference which letters they have, as long as the letters are the same in both of the 2 equations. But the rules all still apply. When we're writing them, we want the same letter in the same column. So I'm going to have 3t plus 4u equals 24, and then t plus 5u equals 19. Okay? So I've written them now in the same columns, and now I need to establish have I got the same number. Hopefully, just looking at it, you don't. And we're going to choose which one we're going to make the same letter. So you know that's your question, or
Yeah. This is the answer should be hopefully no. But will you ever have it as in one is T and U and the other one's like T and V?
no, you will only have the same. Okay. So am I going to make the first or the second, or am I going to do T?
Okay.
Sorry, am I going to make the T or the U the same? The T, yes. So it means I'm going to multiply the second one by what value? Negative 3, yes? Tanya, are you happy if I go straight to multiply by negative 3 now? So because this first one is 3t, well, that's positive, and this one is a positive 1. So if I multiply by 3, I would have 3t. So I need to have an opposite sign, so I need to multiply by negative. Yeah? So negative 3t minus 15u equals 3 lots of 19. Oh, awkward. Oh, you don't need a calculator.
I couldn't figure it out.
Negative 57.
Oh. I thought you just do 3 times 9 and then add that to 30, but I didn't really think
Right, okay, so this is awkward. So if you're doing 19 multiplied by negative 3, what's 10 multiplied by 3?
30.
30.
And what's 9 multiplied by 3? And add those two together. You get
See, I knew that.
You're a genius.
I don't know. Alright, so now we've got our situation where we can put our box around it.
Yeah. You put the other one on top.
Yeah, totally. Yeah. I just rewrote my other one so that it it was already next to it. That was good. No, it wasn't. So it was next to it. I like to put them next to each other. Right, so my box is round it. I'm now going to add them together. So I've got negative 15 plus 4.
Or 4 plus negative 15.
Or 4 plus negative 15. Yes, I need to put it in there. So for this one, it wouldn't, they wouldn't get asked for a completeness because it's not X.
I feel like T would be
And negative 57 plus 24? So U would be negative 33 divided by negative 11, which gives me positive 3. And now we need to substitute that back into something to find T. Which one is the bestest one? Yes, there's the second one here, yes? Yes! She's very proud this time. Well, I think it's the best one because we've got T on its own. So you've got T plus 5U equals 19. T plus 5 equals 3. I'm using the second one. Because T is already on its own. So T plus 15 equals 19. T is 19. Shush! It seems a bit zoo-like.
You always say that.
No, because you always sound zoo-like. So T is 4. It's just weird, isn't it?
Always like before is the number. You know, like I don't like. Oh. I noticed it was mine. Look, I said 3T plus 4, and then bracket 3 equals 4, and the answer was 4.
Oh,
And then